Hello teacher. Today we ask group 1 consisting of Chu Nguyễn Hoàng Sơn, Nguyễn Hồ Quốc Bảo, and me, Nguyễn Quang Tùng. We are thrilled to present our final project for deep learning course. Our presentation centers around the subject of driver drowsiness detection using convolutional neural network. This is the table of content. We have a part. Part 1 is introduction, and then background and knowledge, library and process flowchart, dataset, model architect, training, demonstration, and conclusion. So, first of all, I'm going to talk about introduction. This is the reason for choosing the topic. There are many reasons why we choose to explore this topic. Driver drowsiness detection using CNN, and here are a few possible reasons. The first one is importance of road safety. The second is potential impact, and then the advancement in deep learning, research gap, and finally career opportunities. In conclusion, the topic of driver drowsy detection using CNN offer many benefits, including improved road safety, potential career opportunity, and opportunity to contribute to scientific research. The next slide, I want to talk about background knowledge. This is all knowledge we need to know. First, before we start to program this topic, the first one is convolutional neural network, and then a Python deep learning, TensorFlow. We need to know pre-process data for machine learning tasks, and we need to understand the principle and technique of model training and validation. We need to know performance metrics, understanding the principle and challenge of developing real-time system, and understand the strength and limitation of existing methods for drowsiness detection. And then this is all library or packets we need to implement. As you can see, TensorFlow, Keras, we import drop out, sequential, callback, scikit-learn, and OpenCV, NumPy, Pandas, OS. Besides that, we need to import play sound, threading, and time. For specific, we're gonna talk about this later. And then the process of flowchart. As you can see, at the start, we're gonna check key. Does key equal Q or escape or not? If yes, we're gonna stop. If no, we're gonna detect phase and locate I, and then we use our model to recognize I state. If I is closed, yes, we're gonna calculate cow equal cow plus 1 and go back, check if I close. Yes, we're gonna do this again, and if no, we're gonna go back to check key does key equal Q or escape or not. And then after we calculate cow equal cow plus 1, we're gonna check if cow more than 10. Yes, we're gonna play alarm, start alarm sound, and if no, we're gonna restart cow equal 0 and go back to check key again. Then I want to talk about the dataset. Our dataset used in this project is subset of largest dataset available at Kaggle presentation and communication tool that can be used as demonstration, lecture, speeches, reports, and more. Is mostly present before an audience. Our dataset have four folders: close eye, open eye, yarn, and no yarn. Close eye have, four folders have about 700 images. Um, and next, I want to talk about model architect. As you can see, the image right over here. We use model sequential and convolutional. We have four convolutional layer. We use batch normalization in smart boolean with bool size is 2 multiply 2, and activation function right here I use ReLU to decrease the vanishing gradient and exploding gradient. I use he normal, and then I use drop out to the degree overfitting. And I have two layer right over here is fully connected layer URL and submit activation function. The last function is chemical cross entropy with optimizer in Adam and magic. I use the accuracy. So the total parameter is you can see 500,000, about 500,000. Training, I trained this model over 50 epoch. And beside that, I use two callback. They are early stopping with Batson equal 10 and model checkpoint set with argument set base only equal true. And as you can see the learning chart right over here. I think it's good because it's look like fit.
Hello teacher, I'm Bảo, and now I will talking about the driver Drowsiness notebook. First of all, we import some library, and then we create a label variable. Here I a label variable, and then we show a random image here. After that, we create and show an image array. I will put the image shape. After that, we display an image of a yawning face without a background using an array representation of the face images. This code here, we exactly extract only the face region from both yawn and not yawn images. Here we will return two variables, 0 and 1. For the code here, for detect the closed and open eyes, we will output the variable E2 in 3. Next, we expand the dataset by adding more data and convert data into an array format. And we will create a new variable to store of the dataset, and where the output of the variable is 0, 1, 2, and 3. Next we separate the label and feature into the dataset. We create two array x and y to separate the label. Next we reshape the image x and perform the label binarization. After that, we will set the variable of the y array, and we will return the y to see the result. Here's some result of the array y. After that, we change the text split by this code, and we will output the length of the text. Here our example here return an result here. After that, we import some dependency here and set a data argumentation here, and then we build a model. Some model here, and you can see yes, a lot of model, and that is after that we change this model by this code here. After change successfully, we will show the image of diagram about the training. Here you can see the training accuracy and validation accuracy here. We save it model. We save the model. We have a history here to see the history of the training model here, and we save the model again. After that, we create a prediction. Here is the prediction here. We create a prediction, and then we output the value of the prediction here. We create a classification report here. I will create a label with for variable. We create an array with for variable here, yan, not yan, close, and open. After that, we import some library, and then we create a prediction function here. Prediction function here, and our set that the variable represent for yan is 0, 1 for no yan, 2 for close, and 3 for open here. And this is all of the code in the Drowsiness notebook. Thanks teacher for listening my presentation.
And then about the demonstration, some will talk more specific.
Hi, lecture 1. I am Chu Nguyễn Sơn from Week 1, and now I'm gonna go through a little bit about our project, Drowsiness detection. So first, over here we can see that we are using the data from couple website with 4 different labels or close, no yarn, open, and yarn. But in this project, we only use 2 labels that are close and open for demonstration, because we only do this so simply. First, we go ahead about this function. So this function is basically just a short alarm when it detects the drowsiness. Here is we can see that I have not the comment for easier for us to read. First, we're gonna init a label, then the instance for face and eye detection using the cascade classifier, because this is the most popular one and most easiest one to use. Face, left, right, and right eye. We're gonna use this model over here. This we will need how when I upload. So in this project, we use 10 frames to count if the eyes of the user are closed or not. So if the frame reach to 10, then it will play the alarm that it will wake the people up. So this is in the need of sound like a pass. Here the sound on and sound directories. This is the status. And the previous frame and next frame is for just for FPS calculation purpose. So we start the video capture. Um, over here we also use the histogram equation to enhance the contrast because the data we use that is about the perfect environment. So in case the environment, the light is not good enough, we use this histogram calculation to enhance it a little bit, so the detection will be much better. So first thing about drawing a rectangle for the face, when we have the coordination of x and y, the width and the height, we will use a color gray, which will crop the frame as an image using the frame scale. The right color is similar to that, but instead of gray, it will be colorful. And left eye, right eye, we use the detect multi-scale from the frame that we have come or cropped above. Here's two things about draw rectangle the left and the right eye. So basically to this, both are similar in the calculation and algorithm. We use the ground color, resize and add type both here. Then we will report it to the array. So this is a lot of work to do, and it will set the status here. The status apply to each eye. Status 1 to the right, to the left, and status 2 to the right. So what happens if our eye closed? Then it will start counting. And I have said before that the status is applied to the eye. So if the condition is met, the frame will count that from 1 to 10. But when it reaches 10, it will show the drowsiness alert and play the alarm. It's really loud. Here are the calculating FPS for displaying. So now I will run the demo to see. So here the demo that I have captured before. So in this project, it will work best if we are not using the classes, because the data we use from the category is really simple and it doesn't have a lot of image for all the like in a dark room or when the people are using different kind of classes. So it only detects the basic face. Here we can see that when I am only close a little bit, if we change eye close here, FS over here. Now when it reaches 10, it will show this browsing alert and play the sound here. There one witness of this process that we are using the cascade classifier of OpenCV. So sometimes it will not detect our face correctly, as we can see here. It is detecting minus at the eye. So it still is not optimized yet, but it has the dispatch. Thank you for listening.
For conclusion, we have strength and drawback. Strength, high accuracy, real-time performance is good, and developed model can be easily scaled to include additional features or sensors for more comprehensive driver monitoring. About the drawback, I have two drawbacks. The limited dataset size and features, and object detection use the cascade of OpenCV. It's not stable. It's unstable, so it is not good for detect. And about future improvement, we can use larger and diverse dataset, multimodal feature, explainable AI, or we apply online learning or hybrid model, or we can use integration with a vehicle system or extended testing. These improvements have the potential to enhance the accuracy, reliability, and rework of the developed drowsiness detection system, further contributing to the field of driver safety and improving road safety. This is information to conductors, and thank you for listening.